Okay, let's see what happens if we have a wave um, that reflects against a wall. So in other words, we'll have a rope, we'll tie one end of it to a wall, um, and then initially we'll excite a wave on it. It's moving with some velocity v to the right. Okay, and so we're going to say that we have this end fixed. So what we would see is that at some later time, it's going to get to the wall, and then the wall is actually going to start to pull it down. Okay, so this wave is still moving to the right. So right after it's reflected on the wall, now it's going to be moving to the left, and we see that we have inversion. Right? We've inverted the wave. It began on the top, it hit the wall, and when it reflected back on the bottom. And so then sometime later it's going to be even further along the bottom, traveling to the left. Okay? Now we'll look at an almost identical situation, but this time we're going to use a string that has an open end. But the same deal, we're going to start a wave moving to the right. Okay? Now, when it gets to the other side, when it gets to the wall, it's just going to move up because this end's free to move. So because of that, if we look back at it a little while later, we see that now the wave's still on top. So in other words, there's no inversion. Okay, so this is the basic idea. If we hit a fixed wall, we get inverted. If we hit if we have an open end, then we won't have any inversion. Okay, but there's other ways that we can. So that's reflection. We can also have a reflection with a transmission. For example, let's say we have a wave, and let's say we're on a very thin part of a rope, but then it's tied with a knot to a much thicker rope. And this wave is moving toward the thicker rope. Well, afterwards, so the thicker rope is kind of like hitting a wall, right? It's like hitting something harder. And so that wave is going to be inverted and moving back to the left. But there's also going to be a wave that it induces on the thicker rope. And that's still going to be in the same direction as the original wave, above the rope and propagating to the right. So we see the reflection was inverted, but the transmission wasn't. So now we'll look at the exact opposite situation. We'll say that we have a wave that's on a thick rope, and then it's gonna continue to propagate, and it's gonna reach a point where we hit a thin rope. Well, so in this case, the thick rope is going to bounce back again on top. So a thick rope to a thin rope is not going to be inverted. But then if we look at the transmission, it's also not inverted. So they're both still above. Okay? And remember we said that a thinner rope is going to travel faster. So we see that if we go fast to slow, we have inversion, but only in the reflected component. We still have no inversion in the transmission. But if we go slow to fast, we have no inversion. And really, looking at this model, we see that hitting a wall is just kind of a special case where, the wall is just like a really, really, really thick rope that's so thick that it's not going to move at all. And so, so that's a way that if you can just remember one of these situations, you can connect them together. So you know that a wall is going to behave the same way as, as a fast rope hitting a thicker rope. Whereas having an open end is the other way around. So having an open end is going to behave in the same way as having a thicker rope hitting a thinner rope.